Today we're going to be giving you guys some graphs and analyzing some information about those graphs. A lot of this we have gone through: domain, range, increasing, decreasing, positive, negative. I put the new stuff at the top here to give you guys some definitions, and we're going to point these out in some examples. So what we're going to talk about today, different than anything you guys have seen before: relative maximum, relative minimum. The relative maximum, greatest value of the points in a region on the graph, it's going to be the y value for all of these questions here. Relative minimum is the least value of the points in a region on the graph. That's going to be your y value. And now, these two down here, what we call absolute maximum and absolute minimum, we'll get into this more on the graph, but if you have an odd degree polynomial, one end of the graph goes up to infinity, the other graph goes down to infinity. So what we call absolute max and absolute min, those don't exist for any odd degree. Okay, now an absolute maximum is literally the greatest y value that you can find on the entire graph. And if you have an absolute maximum, it's not going to exist for an odd function, and it's not going to exist if your end behavior is even and it goes up, up. So this is really only going to exist for a graph that has an end behavior that's down, down. And then the absolute minimum is kind of the reverse of that. It's the lowest y value of the entire graph. Doesn't exist for an odd function because the ends point up and down to infinity. And you're not going to have an absolute minimum if your end behavior is down, down. So we're going to get into this in the graphs here. Okay, so this one's a little bit easier to see than the graph here. This is the end behavior here goes up at the beginning and down at the end. So that's going to be negative, and anytime the ends point opposites, that's going to be odd. Now, this goes up to infinity, this goes down to negative infinity. So there's no absolute maximum or minimum for this graph because we don't have an actual value. It goes to infinity. Now, what we call a relative maximum, now this goes up forever, but this has like a little bump to it. And so it would be the y coordinate of that point. And then again, you don't have an absolute minimum, as this goes down forever, but on this little window here, this little bump would be what we call a relative minimum. And then x-intercepts, where you cross the x-axis, y-intercept, where you cross the y-axis. Now, for this graph here, these point these out a little bit nicer, but I think it's kind of hard to see the graph, so I'm just going to kind of highlight it real quick for us. Okay, now this is an even function. So if you guys notice this, this points down forever. So this is going to go to negative infinity. This side's also going to go to negative infinity. So that says there's no absolute minimum. Now, relative minimum and maximum exist here. Now, I have two kind of places here where we turn directions. And so here, this point here is the absolute top of the graph. There is nothing above that point. Everything else is below that. So that's called an absolute maximum. This little bump here, because it's not as high as that one, is called a relative maximum. And then your relative minimum. Again, you don't have an absolute minimum because this goes down to infinity, but this little bump going on the other side here, that's called a relative min. All of these values can only exist where your graph switches direction from increasing to decreasing. So absolute, relative, any of those has to be at a point where you switch from increasing to decreasing or decreasing to increasing. Okay, so just going to go down to my example. Have the equation here. You don't have to factor this or anything, and I have some points, and you'll see kind of these numbers are not the greatest, but I just want to show you how to find domain, range, zeros, intervals of increasing, decreasing. Then we'll use the same graph, and I'll just draw on it differently for positive, negative, and then talk about the relative max and min. Okay, so for this first graph, just in general, this is going to end up going to the left forever. This is going to go to the right forever. So your domain is going to be all real numbers or from negative infinity to infinity. We'll cover the whole x-axis. Now, this will also cover, this goes down forever and up forever, so it'll also cover the whole y-axis, so negative infinity to infinity on interval notation. Now, the zeros, all you're looking for there are where does the graph cross the x-axis, and it's the x value. So right here, I've got one at -5, I've got one at -2, and I've got one at 3. So those are my zeros. Just write those down. Y-intercept is where you cross the y-axis. So this is the y-axis. So if you look right here, you just need the -30, or you can write the point, whatever's easier for you. But the y-intercept would be that point, 0, -30. The y-coordinate there is -30. And then increasing, decreasing, just a little throwback. We did this with quadratics. So if you trace the graph from left to right, if you are drawing up, you are increasing, and that's going to switch over. It's called a turning point here. And then I'm drawing down, so I would be decreasing. And then another turning point here, and then we're going to be increasing. Okay, so for this, we have 3 different intervals, and if you guys remember, I like to kind of write this on the graph. So these switch over at values of the domain. So you're looking for x values here. Where does this switch over? So I'm going to say all the way to the left forever would be negative infinity. Now this whole time as I'm traveling here, I would be increasing on my graph, and that stops at this x value, which is -3.667 there. Okay, then we switch over and we're decreasing until I get to this x value, which is actually, this one's a nice number. This is just 1. And then at 1, I switch over again, and the rest of the graph is increasing. If you want to write those values on the graph, you can literally just go ahead and make your intervals from there. Just read them from left to right. So the first interval is increasing because I was drawing up. So I'm going to list that here from negative infinity to that -3.667. Then the graph we're drawing down is decreasing. So let me grab a different color here. So from the -3.667, as I'm traveling this way, all the way until I get over to the 1, that part of the graph is decreasing. So -3.667, comma 1. And these are going to be parentheses because when you get to that turning point, you're not considered to be increasing or decreasing because you're flat. So it's just going to be a parenthesis, no brackets here. And then the rest of the graph, if you guys look at this, at 1, as I'm traveling from left to right, then the rest of the graph starts to draw up. So 1 to infinity is going to be an increasing interval. Remember, if you have more than 1, you just put a little union symbol there, and then 1 to infinity will be the rest of the graph. Okay, now I just repeated the exact same graph, so it's exactly the same picture, but I like to do these differently, positive, negative, and increasing, decreasing on like a different picture so it's easier to see. Okay, so positive is any interval where the graph is above the x-axis. So right here and right here. All right. These switch over at the zeros, so I might jot that down just so I remember. So intervals of positive and negative, they switch over at the zeros. Okay, now where the graph is negative is where you're going to be under the x-axis. So I am just trying to locate a different color. I'll go ahead and use the orange here. So this part of the graph, all negative y values, this little loop here. So I have 2 intervals of each, and I'm just going to kind of do the same thing I did on the previous graph. I'm going to write these on the x-axis. So from negative infinity until I get to -5, that little piece of the graph is underneath the x-axis, so that would be negative. So I'm going to say negative infinity, -5. Now, at the -5, then we switch over and we're above the x-axis, so we're positive until we get to the -2. Okay, so for that one, I'll just use a little different color here. So from -5 to -2, Now that part of the graph is above the x-axis, so I'm going to put it on the positive. Okay, then we dip back down below from -2, this whole part of the graph's underneath, all the way till we get to 3. So that's going to be my next negative interval. So -2 to 3, all that has negative y values. And then remember, all the way to the right, I'm just going to write down infinity here. So the rest of the graph is positive, so that switches over 3 to infinity. So I'm going to put that with the positive. Okay, now relative max and min and absolute max and min. Okay, so remember, if you have any type of odd function, so go in opposite directions, this end points up to infinity, this points down to infinity. So if you're going to infinity, your absolute max and min don't exist here. So you can write none or not applicable or just draw a line through it. Now we do have a relative max and min here, and that's going to be these little bumps. So these, any of these we're talking about here, are going to be the y values. So I'm just going to circle this on the graph. This is going to be your relative maximum, and you just want the y coordinate of that point. So on this window, little top bump here is going to be 14.815. And then my relative minimum, the little bottom bump down here, just want the y coordinate of that point, -36. And then again, we don't have an absolute because one side goes to infinity, one side goes to -infinity. All right, so similar question, just a little bit different looking graph. And I went ahead and I guess I did stuff a little bit different order here. So the zeros just tell me where it crosses the x-axis. So I'm going to write down -2. I'm going to write down 0. And I'm going to write down 4. So these have these points kind of highlighted here so you can see them. Y-intercept is actually, where does the graph cross the y-axis? It's actually in common with one of the zeros because I'm going through the point 0, 0. Okay, now increasing, decreasing, I'm just going to trace again like I did on the graph on the front. So left to right, here I would be drawing down, so that would be decreasing. Then here I switch over and I'm drawing up, so that would be increasing. Drawing down, this would be decreasing. And then drawing up, this is increasing. And so I'm just going to write those intervals right from the graph. So let me come back over here. Remember, this is always traveling from left to right, so all the way to the left would be -infinity, all to the way to the right would be +infinity. Now these switch over at these little breaks here, so I know these numbers are not the greatest. But right here, this is -1.386. This is 0 right here. And this over here is a decent number. This is 4. Okay, so let me just write them down. Now, the first interval we come to there, from -infinity till I get to this -1.386, that is drawing down, so that's decreasing. So we're going to put it here. -infinity to that -1.386. Then, that same x value, I switch over to be increasing. This is just real short. So -1.386, whoops, until I get to the 0. So that's my next interval there. Then at 0, I'm switching over to decreasing. And this is decreasing until I get to this x value. Forgive me, I know I put 4 and I was looking at the 0. Forgive me, it switches over here, the 2.886. Okay, so we're going to use the x coordinate there, not of the 0 of where this switches over. I was thinking about positive, negative. So from 0 to this 2.886, we're decreasing. So we're going to put it here. So 0, 2.886. And then the rest of the graph, starting at that same value, 2.886, the rest of the graph is increasing, so as I approach infinity as I'm traveling to the right. Okay, we're going to move down. This is exactly the same graph, but just want to use different highlighters for positive, negative. So positive is anywhere the graph is above the x-axis. And this question is a little bit weird because of the bounce that's going on here. So this is negative. This is negative. Okay, now when you're doing intervals of positive and negative, those switch over at the zeros. So again, all the way to the left, negative infinity, all the way to the right, positive infinity. So this is switching -2. I know this is going to be weird, but we're going to have a separate interval here, 0 and 4. So the first interval I have from negative infinity to -2, that's above the x-axis, so that's going to be positive. Now, this is weird, but this interval here from -2 to 0, we are below the x-axis, so we're negative, but right here I come back to the x-axis, so that is not considered positive or negative. So I'm going to write two separate intervals here. Even though you guys can see this whole thing is the same color, you have to distinguish a different interval, because if you touch back at the x-axis, that's not considered positive or negative. So in terms of the negative, from -2 to 0, the next interval is also negative, but like I said, I have to separately define this. So starting at 0, remember I'm traveling to the right, till I get to the 4. And then at the 4, I switch back up to being positive, so the rest of the graph from 4 to infinity is positive. All right, slide this up. Okay, now, relative max, min, absolute max, and min. So this points up forever. So there is no absolute maximum here. However, this does have an absolute minimum because there is an actual bottom to this graph. And I am totally just realizing we did not do the domain and the range. So let me just do that real quick as I'm here, because I know it's going to ask you that on your homework. Okay, now left forever, right forever, the domain negative infinity to infinity. The range, however, you do have a minimum value, and I'm going to have a bracket here. The first y value I touch there, I'm going to put a bracket, negative 45.335, comma, that goes up forever to infinity. So make sure I write that down, because I think I skipped that or lost it off the paper when I printed it. So domain and range there for you real quick. Okay, so you have a relative max, little up bump right here, and I know that's weird, but it's going to be the y-coordinate of that point, which is 0. So this is my relative max. Okay, the rest of the graph goes up forever, so we don't have an absolute maximum. Relative maximum, y-coordinate of that point. Okay, now I'm going to look at two things here, this point and this point. This one is considered the relative minimum because I have this one here, which we're going to call the absolute minimum. So for your relative minimum, you're just going to write the y-coordinate of that point, that negative 6.353. And for your absolute minimum, that's going to be negative 45.335. Okay, so relative, we have two bumps at the bottom. The one that's not as low is the relative. The one that is the lowest, that's the absolute.